Hello everyone, and I am turning this x299 system, and I want to talk a little bit about this platform and what you can do with that, because I really dislike it, mostly because most of the buyers of this kind of machines just bought it because back then it was the high core count that you couldn't get with the desktop i7s that were only 4 cores, but they just bought it for the kind of application that actually needed only 4 cores, like gaming and music production. And so let me get to some settings. So here you can see the offsets, the undervolt offsets. The mesh is currently running at 29x, which is a little bit higher than the default 24 that you get without XMP. And for some reason this Asus board, when you enable XMP, is at 27, which is fine. Makes sense. The Limpax cores, 30 gigabytes, 740. The microampere 5B is 198. So let's get to the here latency 66 nanoseconds. So let's get to the BIOS. Let's briefly go through why this machine in particular, how it was built, is awful, and it's perfectly reasonable because the people that build this kind of machine make no sense, and they build them in a way that makes no sense. So you have 4 intakes, Noctua fans, which are super expensive, small from the intake, and Noctua 90 millimeters radiator, and then no outtake fans. I put this myself, this janky AliExpress fan, because it's the only outtake you have, and this is almost all closed, and there are no outtake fans. And if you look at the PSU, it's now on because we are in the BIOS, I think, but during normal operation it's totally off because it's super oversized for this audio machine that has a passive GPU. So this fan never spins, and you get a build up of heat around here that is terrible, that's awful, and the CPU just never goes back to normal temperatures. Well, so that's how you waste a lot of money with expensive components and you get an awful machine, because this machine had to be built for real-time performance because it was built for audio, and the person that uses this machine only use it for recording guitars. So it doesn't make any use of the other cores, only the one that he uses for recording. He doesn't do like huge productions. He doesn't use a lot of libraries, and this machine has, at least this guy, I know the guy that built this machine, and he usually only puts 2 sticks of RAM for x299. At least in this machine he put 4. That was a step up from his usually. So the machine has XMP 3000. It's Hynix 8i DDR4. I run it at 34x. Again, the cache. This is the mesh in the x299 systems, and the mesh is like the interconnect between the cores, very similar to the older ring bus, but it's made differently. It was built, it was created because Intel wanted something that could be easy to scale up and down with the number of cores without having to redesign the CPU from scratch. So they could basically use their CAD software for creating CPUs and just add more cores without having to have a new design from scratch. But this is very bad for latencies, for internal latencies, because the internal latency from different cores are all different, which is fine for any kind of application that doesn't share data between cores, like if you have a server that runs a lot of virtual machines, the virtual machines actually you don't want the virtual machine to talk to each other, because that would be awful for security. So each core is basically independent, and they don't have to share anything, and you don't mind about the inter-core latencies. But the inter-core latencies for x299 are awful. They are all over the place because of the mesh architecture, and this makes the real-time performance for this kind of platform awful. This is the 8-core, so at least it's like a small die for this 7820X. This has a small 8-core die, which is much better than the bigger one. That is, I think the bigger one is 22 cores, and then they carried up for desktop. They got up to 18 cores. On the servers they got up to 22. As far as I remember, maybe it's 24. I don't remember exactly, but I think it's 22. Here are the timings. It would do 1T, which is fine. I didn't touch it to the secondaries because I was getting mixed results when I did, so I didn't bother. So with this kind of cooling, this is 111 watts limit. The SVID support, this is the reporting from the CPU to the OS, and I guess from the motherboard to the CPU, something like that, about the power consumption. But if you enable it to read the actual power consumption of the CPU, you get much worse performance. So you have to keep it disabled. I don't know why, but it's like that for Asus motherboards. Other things, I tried different load level calibration, and I found out that the default one was 1, and 1 is fine. Works just perfectly. This one, it states that you can lower it to a lower thermal cutoff if preferred, but you cannot actually lower it. Whatever you input, it doesn't work. You cannot use minus. You can only plus it. Asus. Here are the offset voltages. Yeah, these are all maxed. And yeah, the cache voltage, which is the mesh voltage, I could do 28 with minus 50. I could do 29 with minus 10, and then to get 30, I would need more than plus 50, so I didn't bother. And the general consensus on the internet is that you have to run you can run the mesh at up to around 32, up to 32 stable with the right voltage. But I wouldn't do it because I don't like to use a plus offset. I like undervolting. And Encore is minus 150. Lower than that causes problem with booting, but it's actually stable on the system. So I could actually try to tune it differently between booting and runtime value, but I doubt it would make any sense, and I don't like it for stability. And so 134 for the voltages. The system agent is actually apparently not used in x299. I noticed that when I enable XMP, Asus would set it to 0.8, and I find it very strange because Asus usually likes to pump a lot of voltage. I don't know why I ended up using 85, but I noticed some performance regressions, and I thought maybe the system agent would be responsible, but the system works fine at 0.8. And the VCCIO actually makes a difference and it gets unstable after, I mean below 97, I think, 0.97 with this memory and cache frequency. If you use XMP and use 27, I can use it at 0.9, no problem. And yeah, I guess that's all. So yeah, let me just now check this. Okay, just saving the profile. And what else? So it's interesting for this kind of platform that you actually want to decide what you want to do with it, because the mesh clock, as you rise it, you get a lot more heat output, a lot more power consumption. So you can actually tune these machines for multi-core performance, like Cbench scores, basically, or for memory performance with higher mesh voltages. And I guess that Intel wanted to put it at 24 because they wanted to get high Cbench scores. So let's do a Cbench test with this setup. and see the temperatures and everything with my profile. So it's what you want to do with this is, for 99% of the users, you want to rise the mesh frequency and get a good real-time performance, because 99% of the user don't need the multi-core performance. They just bought it because they thought it was cool to have a lot of cores. They thought they would use a lot of cores, but they actually don't use them. And this was made pretty clear back then when all the reviews came up and the performance was awful. It wasn't better than x99. I have an x99 Chinese system here with all junk, and the whole system cost about the same as the CPU, like 200, maybe 150 to 200, 150 euros probably, if you consider the used prices for the stuff. If you consider them new, maybe 200. And it has 7 euros Xeon, and the performance for the Xeon is like half of this for multi-core performance and also for single core performance, but the Xeon X99 4655 has only 2.6 gigahertz all-core clock and 3.2 single core. I think it's an engineering sample, but the latencies are almost the same. So that means that the gaming performance is about like 50% less, and the whole system costs 200, while this one is probably still gonna cost you around 800. It doesn't make any sense to build this. Okay, so here's the score for Cbench R23. And what I wanted to point out is that I can actually run the default 24x mesh clock, the default XMP's memory speed, and get much better multi-core performance, because here I was running at 82 degrees with just a single run. And if I keep going, and with the kind of case that I have here, the whole system becomes a space heater. I will now load the default XMP system and check the latencies there. I will not do Cbench with the default settings because I didn't tune the voltages for the default settings. I didn't tune the voltages for 24x mesh, but I can assure you, that with 24x mesh I can get much better multi-core scores and at the same power target. But I don't want to do that because that's not usual. Because that's not useful for the client. So let's go to reset everything to default. Load optimize defaults. Then load XMP. Of course, we have old core. Let's set the 120 for this at the moment. So I'm not gonna bother with everything else, just loading the default XMP profile and check the latency. But yeah, the client would have been like so much better with the 7700K normal consumer CPU for audio recording and even production. Like, as long as you don't run heavy multi-threaded application that have no communication between the cores, which is almost only server stuff, or Cbench. Because yeah, Cbench actually communicates between the cores with the thread probably, but it's all inside the cache. Let's do it. It would be much better with the default consumer platform. The real selling point for this kind of machines are the high number of PCI lanes, which this machine doesn't use because it's made for audio. It doesn't use like any NVMe storage. I mean, it does, but it doesn't need any arrayed settings, configurations. Here it is. Here are the stock bandwidth and latency. And again, the stock clocks for the mesh. is 27. It was set it to 27 for some reason. Here it is. Now I might do Cbench, but there's no offset thunderbolts. So yeah, not really useful. And yeah, and again, the other selling point for this kind of platform was the bandwidth, which remained uncontested up until DDR5 came out. So 4-channel memory and a lot of PCI lanes, that would make sense for video editing in the consumer space. That's the only thing that I can think about that a normal person would need this machine for, and would need to be like a kind of hybrid machine that has both multi-core performance and a lot of PCI lanes and a lot of bandwidth, and then also do normal stuff with it, because otherwise for other kind of like scientific calculations you might as well get a server. And I guess that's all for the retrospective on x299, but I will sure have to tune some more in the future, and we'll see what else can I make about this. Ciao!